Everyone, welcome to another video of class 10 general science, and today we are going to start with chapter 11, that is human eye and the colorful world. And we are going to start off with the human eye itself. So without wasting any more time, let's dive in directly into today's topic. So what I have done here, I am going to add one image of the eye over here so that you get an idea of what am I talking about, which parts am I talking about. So the human eye, as you can see from the image, is a spherical body. It is completely spherical, and that is because of a compound or a component that is present inside the eye, and I'm going to come to that later on. But this spherical shape is maintained homogeneously all throughout the life of a person, and in any case, if the spherical shape is damaged, that also results in a detrimental effect on the image formation by the eye. Now, starting off, let's move ahead step by step from the first layer into the innermost layer of the eye. So, coming to the first layer is called the cornea. Now, cornea is the portion of the eye that is responsible for most amount of refraction of light in the eye. Now, what we think is there is the cornea, then we have aqueous humor, then we have the pupil, and then we have the lens. Lens is supposed to make the highest amount of refraction or the change in direction of light, but that is not exactly that happens. What happens is the cornea takes up the responsibility to change the direction of the light to the maximum extent, and to the maximum extent is actually relative to what? Relative to the lens. The amount of refraction that will take place in the cornea will not be exactly the same amount of refraction in the lens. Rather, the amount of refraction of light in the cornea is much more compared to the amount of refraction in the lens of the eye. Okay, let's keep lens aside for a moment and let's concentrate on cornea. Cornea, since it has a refractive index different from that of the air, as a result, when light moves from the air to the cornea of the eye, it experiences a change in the refractive index. Now, due to this change in refractive index, the bending of light is much more compared to the bending of light when it reaches the lens. And why that happens, I am going to tell you in a minute. So now, when light comes from air, which is a refractive index, we take it as 1, and it enters the cornea, which is a refractive index of approximately 1.3 to 1.4, there is a change in the direction of light. Now, due to this change in direction, we are going to have formation of images at different parts. We are going to talk about that as well. So, please stay tuned for some time. Now, after the light has entered the cornea, it will reach the aqueous humor. It is a liquid present between the cornea and the iris of the eye. And this liquid is extremely important because it is not only in contact with the iris, but also in contact with the lens. So what the aqueous humor does is it provides nutrition and also it provides the general health of the eye, because it provides lubrication, nutrients, and other requirements of the lens or the other parts of the eye. These are provided by the aqueous humor, and that is why aqueous humor is also important. And aqueous humor also tries to maintain almost a similar type of refractive index compared to the cornea and the crystalline lens or the lens of the eye. So that, keep that in mind, because that context I'm going to take up again in a little bit amount of time. So what am I saying is the aqueous humor has the role in giving protection to the eye, in giving nutrition to the eye, and in also providing a general good health to the eye. The next part of the eye that we have is the iris. Now, iris is just like the shutter of a camera. If you have seen the shutter of any camera, the shutter closes and then it reopens. It closes and reopens based on how much amount of light is required to enter into the lens of the eye. And not the lens of the eye, the lens of the camera. And exactly in the same way, in case of our eyes, the iris will allow how much amount of light will enter the eye. Now, depending on the requirement of how much amount of light is needed, the iris will either close or it will either open. So, it is like this shutter-like structure that whenever it is required to allow more light to enter the eye, the iris will open up, allowing the pupil to become larger. And whenever there is requirement of small amount of light to enter the iris will come closer, making the pupil small. And by pupil, what I mean, if you go near the mirror, you will see a small hole that you can see on the black portion of your eye. That small hole in the black portion of your eye is the pupil, and that is controlled by the iris, when it is larger or when it is smaller. Now, when does the pupil get larger and when does the pupil get smaller? That is the question. Now, suppose you are in a room that is heavily lit. There is good amount of light or maybe high amount of light. In that case, you will always try to just close your eyes a little bit so that you can see things properly. If you open your eyes completely, you will see that because of too much light, you cannot see everything properly. Why does that happen, or how is it controlled? That whenever you try to get your eyes closed, means as there is too much light around you and too much light can be detrimental to your eye. In that case, what happens? The iris tries to close the lid of the eye, means tries to close the lid of the pupil, so that the exact amount of light that is required by the eye to watch any object is allowed to enter through the eye. Now, this requirement of the eye is based on its normal health and how much it can allow light to enter. And in case of, if we take an exactly opposite case, as for example, suppose you go to any room which is extremely dark. In a very dark room, what we try to do is open up our eyes as much as possible. So when we start opening up our eyes as much as possible, what we are trying to do is we are trying to allow as much amount of light to enter the eye, so that even in the darkness we can see some of the objects. Now, that is how iris plays its role. Whenever there is too much light, it will optimize the amount of light that needs to be entered. And remember the term optimize, because it is relative from person to person. Now, for you, the function of the iris or the working of the iris may be different from the function of iris in my eye. Because how much amount of light my eye can bear may not be exactly the same as the amount of the light that your eyes can bear. So iris will try to maintain the optimum amount of light, or exact the correct amount of light to enter your eye, so that there is no damage to the eye and you can also see objects clearly. In the heavily lit condition, the iris will make the pupil small, so that low amount of light can get in, not too much amount of light. And in a dark situation, the iris will make the pupil big, so that even from the dark environment, as much amount of light can be accumulated inside the pupil. That is our next part, that is the iris. Now we are moving ahead, and what we get after iris is the lens, the crystalline lens. The crystalline lens is the real lens of the eye, which will actually help us in creating the image or forming the image. Now, the crystalline lens is a convex lens. As you can see from the diagram itself, the crystalline lens is a convex lens. And as we have studied in chapter 10, reflection and refraction, that convex lenses are converging lenses. By converging lenses, I mean that the rays which will enter the convex lens will converge at a particular point, and that particular point is generally a focus. Whatever we have done in the ray diagrams, we have studied in chapter 10, we have seen that whenever the rays of light enter a lens, after hitting the lens, they try to converge at the focus, always at the focus. So we will see what is the focus of our eye, we will move to that. But before that, we must understand that crystalline lens, as I have mentioned at the beginning of the video, that we may think that the crystalline lens is doing the majority of the refraction, but not really. The major part of the refraction is done by the cornea, whereas the crystalline lens only takes part in fine adjustment of the refraction. That means the last minute adjustments that are needed to be made, the small adjustments, so that the image is formed exactly at the right point or exactly at the focus. Those sort of adjustments are made by the crystalline lens and not the major adjustment. And the reason why I was trying to talk about earlier, when I talked about the aqueous humor, which tries to maintain the refractive index similar to the lens, is because as the refractive index between the air and the cornea is much more different, the values are much more different compared to the values of refractive index of aqueous humor and the lens. As a result, what happens? The refraction is bound to be more in cornea rather than the refraction in the eye lens, that is the crystalline lens of the eye. since the refractive index between the aqueous humor and the crystalline lens is not as much compared to the difference in refractive index between the cornea and the air. I hope you get my point. So since the light is coming from the air to the cornea, there will be more refractive index and as a result more refraction of the light. And when the light moves from aqueous humor to the pupil or to the crystalline lens, in that case what happens, the refractive index is not much different, and as a result the amount of light that will bend is also not going to be too much. That is about the crystalline lens. Now we are moving further inside, and inside the crystalline lens we have this hollow structure that is filled with a fluid, and that fluid is called the vitreous humor. The vitreous humor is another very important part of the eye, and as I have mentioned earlier that there is a substance that keeps the eye completely spherical in shape, and this spherical shape, or to maintain this spherical shape, the substance that is required is the vitreous humor. And vitreous humor will provide some pressure, will apply pressure from the inside of the eye so that the whole eye can stay spherical. In any case, if you lose your vitreous humor, your eyes will collapse and they will shrink, and you cannot form the required image inside your eye. I hope that is clear. And vitreous humor also maintains some or provides some of the nutrition to the eye. Proper pressure, proper nutrition, and proper taking care or health of the eye is maintained by the vitreous humor. So that is all about vitreous humor. And now let us move into the single most important part of the eye, and that is the retina. Now, why retina is so important? Because all the image formations take place in the retina. Now, retina, what it will do is it will form the image, so it acts like the focus of the eye. So whatever light is entering the lens or the crystalline lens, it always focuses at one point, and that one point is the retina of the eye. Retina of the eye will form the image, but there is one catch to it. And what is the catch? As we have studied in chapter 10, that convex lens always forms inverted images. So here the retina also, at the retina, the image formed by the crystalline lens of the eye will be an inverted image. But do you see things inverted? No, we don't see things inverted. Now that you are watching me in the video, or I am watching my camera right now, I don't see my camera upside down. I see it as it is. You don't see me upside down, my legs are up and heads are down. No, you see me as I am, straight, erect, standing in front of you. Why does that happen? Because after the image is formed in the retina, or after the inverted image is formed at the retina, the signal is sent to the brain through the optic nerves. And as the signal is sent to the brain will process the information and give out, or process the data I must say, and produce the information that will make the image look straight. So the function of the brain in this case is to make the inverted image a straight image, so that you don't see the world upside down. Otherwise what would happen is you would see the land is above and the sky is below, because everything would seem inverted. So that is how the retina and the optic nerves and the brain function together, so that we can see everything as they are and not upside down. So that is the function of the retina. Now I missed one part, and that is a very important part, and that the name of that part is the ciliary muscles. The ciliary muscles are present at the top of the crystalline lens. Ciliary muscles are really important because ciliary muscles maintain the focal length of the eye. So whenever the ciliary muscles contract at the top of the eye, as you can see in the diagram, there are the ciliary muscles. When they contract at the top of the eye, what happens to the lens of the eye? They become very thin because they are pulled from both ends, and as a result the lens becomes very thin. When the lens is very thin, the focal length becomes more. Okay, because less the curvature, more the focal length. And when the ciliary muscles relax, what happens is the lens from its thinness becomes a bit more bigger or bulgier, and as a result the focal length decreases, because lower the curvature, lower is the circle, and hence the focal length will be less. That is how the focal length of the eye is also controlled by the ciliary muscles. Now, as we can control the focal length of the eye, that means we can also control the power of the eye. That is what is called the power of accommodation of human eye. Power of accommodation of human eye means we can see objects kept at different positions clearly. It is not that, because if you look into any sort of convex lens, what we see is if it is placed at a particular point, then only the image will be formed at a single point. As the position of the object changes, the position of the image also changes. But if that is the case in case of human eye, what will happen? As the things at different distances are placed, all the things cannot be formed cannot be formed having a clear image in our eye, because we will have a fixed focal length. If the focal length is fixed, in that case what will happen? We can only form clear images or distinct images of those objects that are placed at a particular distance from us. Any other object placed at any other distance from the eye will not be having a clear image in our eyes. Now, in order to tackle that situation, what the human brain or the human body has developed is a adjustable lens. So what we do here, we change the focal length of the eye so that we can adjust to every single object placed at different distances from us. And this change in focal length goes on every single time, every single moment. So whenever you are looking around yourself, the different objects are placed at different distances from you, and those objects can be formed exactly at the retina by actually constantly changing the focal length of the eye. And that is called the power of accommodation of human eye. That is, we can accommodate based on the requirement of the eye or requirement of the position of the object. Now there are two more things called the least distance of distinct vision, or it is also called the near point. And least distance of distinct vision means what is the minimum distance from your eye at which you can see objects exactly clearly. Now what do I mean by that? Take your finger and try to bring your finger very close to your eye. You will see that the finger looks very blurry. It is not at all clear. Now try to move the finger a little bit away from your eyes, and at one point you will see that you can see the fingers exactly clearly or very distinctly. So that is the distance from your eye to your finger, the minimum distance at which you can see the finger distinctly. That is called the near point or the least distance of distinct vision. So for a normal human eye, the least distance of distinct vision is 25 centimeter. Now when you measured your one in your home or at your home, you may say that, sir, my one is not same as 25 centimeter, it is different. Well, the thing is 25 centimeter is not for everyone. 25 centimeter is an average taken for all the human beings around the world. So it may not be exactly 25 for you. There may be a plus minus of certain value for you. So go ahead and check out your least distance of distinct vision. What is the minimum distance at which you can see objects very distinctly? Now there is another point called the far point, and the far point means what is the maximum distance up to which you can see things clearly. And for a normal eye, the far point is generally infinity. Why do we say infinity? If you have a normal eye without any specs like mine, so don't worry about if you have specs, that means your eye is already damaged to a certain extent, not completely, to a certain extent. But people with completely normal eyes, if you go outside and if you look at the moon at night, you can see that you can clearly see the moon. Obviously not the details of the moon because it is so far away, but whatever can be seen, you can see things pretty clearly. That means the moon is very clear to you. But people who are having problems in their eye, if you open your specs and go ahead and try to see the moon, you will see the moon is blurry. The moon is also not distinct. That is where we make the difference. If you wear the specs and watch the moon, then you will see that the moon now is looking very clear. So with the specs, what we do, we make the far point up to infinity. We try to match with a normal eye. But what normal people with normal eyes or with a healthy eye, what they can do, what they can see is that the far point for them is infinity, but the near point is around 25 centimeter. That is about the near point, far point, and the power of accommodation of the eye. That is all about the different parts of the eye and how the eyes accommodate based on the requirement. I hope you understood today's video. I have provided the image and I hope that you have understood as I moved along through the different layers. So if you have any confusion regarding any topic that I have discussed today, make sure you ask the question at the comment section in your chat box or in the WhatsApp group or personally WhatsApping me. So whatever you want to do, you can do, but you can ask me all your doubts. I'll be there to clear them out. Thank you everyone for watching, and until next time.